The frontier AI era has gone local. Qwen 4 is not here yet, but the architecture behind it is, and you can download it today. It is called Qwen 3.8 Flash Next, an open-weight model that activates only 6 billion main parameters per token, yet is already beating DeepSeek v4 Flash across major coding and agent benchmarks. And then it does something even more surprising. In Qwen's published table, Flash Next beats Claude Opus 4.6 in every available head-to-head comparison except one, not merely challenges it, beats it. SWE-bench Pro 62.5 versus 53.4, Multilingual Software Engineering 81 versus 77.5, Professional Job Tasks 55.7 versus 36.6. Opus wins humanity's last exam. Qwen wins almost everything else where both models have a reported score, including coding, instruction following, computer use, vision, and practical agent work. And unlike Claude Opus, you can own this model. You can download it, run it on a high-memory workstation, connect it to your own tools, and keep your private code and documents inside your home. That creates a completely new choice. Do you continue paying up to $200 every month to rent frontier AI from the cloud? Or do you put that money toward a machine, perhaps a high-memory M5 Ultramax Studio, that can run powerful open models for years? In this video, we will examine the new architecture that could power Qwen 4 and compare Flash Next with DeepSeek and Opus. Then we will expose the cat behind the benchmark numbers and calculate what kind of hardware you actually need. By the end, we will answer one question: is Qwen Flash Next the first true frontier AI agent you can own? Flash Next is not Qwen 4 itself. Qwen describes it as an experimental preview of the architecture that will underpin Qwen 4. Its main model contains 125 billion parameters, but activates only 6 billion per token. It also includes 51 billion n-gram embedding parameters and a 4 billion multi-token prediction module. Qwen's sparse attention reduces the cost of processing long contexts. Gated residual connections control how information travels through the network. N-gram embeddings add capacity without demanding the same amount of computation as traditional parameters. The result is a model with roughly 180 billion total parameters, a native 200,000 token context window, and the ability to extend toward 1 million tokens. The promise is enormous capacity with dramatically lower active compute, and according to Qwen's benchmarks, that promise is already working. DeepSeek v4 Flash is the real local rival. DeepSeek is powerful, open-weight, and designed for serious coding and agentic work. But it is also larger, activating around 13 billion parameters compared with Qwen's 6 billion. Despite that, Qwen leads several of the most important published tests. On Deep SWE 1.1, which measures realistic software engineering performance, Qwen scores 58.7%. DeepSeek scores 54.4%. On SWE-bench Pro, Qwen reaches 62.5% against DeepSeek's 56%, and on Tool Athlon, a test of real-world tool use, Qwen scores 73.5% while DeepSeek reaches 70.3%. These evaluations matter because an AI agent needs more than coding knowledge. It must inspect an unfamiliar environment, choose the correct tool, understand the result, recover from mistakes, and continue working toward a goal. That is where many local models collapse. They can produce an impressive function from a clean prompt, but lose control when the task includes a real repository, terminal errors, incomplete documentation, and several connected decisions. Flash Next appears to be built for exactly that kind of work. On CoWorkbench, which measures long-horizon office and productivity tasks, Qwen scores 73.9%. DeepSeek v4 Flash scores 45.1%. On JobBench, Qwen leads 55.7 to 41.3. DeepSeek is still formidable, but across these agent tests, Qwen is not winning through size. It is winning through efficiency. Now we reach the comparison that changes the entire story. Claude Opus 4.6 is a closed frontier model. Anthropic has never disclosed its parameter count, although informal estimates place models in this category in the trillion-plus range, potentially around 10 times the total size of Flash Next. That estimate is unconfirmed. But the benchmark table is public. Where both models have reported scores, Qwen beats Opus 4.6 across almost the entire table. SWE-bench Pro, 62.5 versus 53.4. Multilingual Software Engineering, 81 versus 77.5. Repository-level code generation, 48.1 versus 47.6. Co-workbench, 73.9 versus 68.2. Job bench, 55.7 versus 36.6. Instruction following, 81.3 versus 62.5. Competitive coding, 91.9 versus 88.8. Even on GPQA Diamond, a difficult scientific reasoning benchmark, Qwen narrowly leads 91.7 to 91.3. The same pattern continues through the available vision and multimodal tests. FlashNext leads on mobile use, real-world perception, visual mathematics, long video understanding, and multimodal tool use. Opus has one clear victory. On humanities' last exam, Opus scores 40% while Qwen reaches 35.9. So Opus may still have an advantage in extremely difficult, multidisciplinary reasoning. But in the practical categories, FlashNext was built to target coding, tools, vision, computer use, and long agent workflows. Qwen's published results show a decisive victory. An open-weight preview of Qwen 4 is outperforming a major Claude flagship across almost every available direct comparison. That is not normal progress. That is a warning shot. Before we declare Qwen the winner, there is an important catch. These results are primarily published by Qwen, and not every comparison uses identical conditions. For SWE-bench Pro, Qwen tested the open models with the Claude code harness, specific sampling settings, and a 256,000 token context window. The Opus 4.6 max number is Anthropic's officially published result, not necessarily a new run inside the identical Qwen setup. Other tests may also differ in prompts, tools, time limits, context, and the number of attempts. So this is not a perfectly controlled boxing match. We cannot conclude that FlashNext is universally more intelligent than Opus. But the caveat does not make the results meaningless. Even if independent testing reduces some of these gaps, a downloadable model operating in this performance class is still a breakthrough. Would these results convince you to invest in local hardware, or would you wait for independent testing? Tell me in the comments. FlashNext does not win everything. On NL2 Repo, DeepSeek v4 Flash scores 54.2%, while Qwen reaches 48.1%. That benchmark focuses on turning natural language instructions into repository-level implementations. If that is your primary workflow, DeepSeek may remain the stronger choice. This is why the word best requires context. Opus may still be stronger at broad, difficult reasoning. DeepSeek wins some repository tasks. Smaller local models are easier and faster to run. But FlashNext may offer the strongest overall combination of coding, multilingual ability, vision, tool use, computer control, and long-horizon agent performance. It does not need to win every individual test. It needs to provide the best complete agent on hardware a serious individual can own. Yes, but not on an ordinary computer. 6 billion active parameters does not mean the model occupies the memory of a 6B model. The full architecture contains approximately 180 billion parameters. Those weights must still be stored, together with the context cache and runtime overhead. With aggressive 4-bit quantization, the raw weights could approach 90 gigabytes before that additional memory is considered. So 100 gigabytes of available memory is near the lower boundary. It may work with the right quantization and a controlled context length, but 128 gigabytes or more is a much safer target. That could mean a multi-GPU workstation, or it could mean Apple Silicon. The M5 Ultra Max Studio can be configured with up to 512 gigabytes of unified memory. Apple is explicitly positioning it as a system capable of running enormous language models entirely on-device. You do not need 512 gigabytes specifically for FlashNext, but high memory configurations provide room for better quantization, longer contexts, and other tools running alongside the model. Speed will depend on memory bandwidth, software support, and inference optimization. But the important point is that a realistic path now exists. A quiet machine sitting on your desk can hold an agent model approaching the capability of frontier cloud systems. Claude Max 20X costs $200 per month, that is $2,400 every year. A high-memory Mac Studio or GPU workstation costs considerably more upfront. It uses electricity, requires setup, and will not automatically be cheaper than a subscription. But this comparison is about more than price. It is about ownership. When you subscribe to a cloud model, the provider controls the limits, pricing, privacy rules, model access, and what happens next. When you own the hardware, you control the system. Your source code stays local. Your private documents stay local. You can connect your own tools, modify the agent, choose your inference software, and run long tasks without watching a usage meter. The machine can also support development, video editing, rendering, image generation, and future open models, not only Flash Next. You could even put part of that recurring AI budget toward monthly payments on hardware you eventually own. For occasional users, the cloud will remain easier. But for developers and creators who use AI every day, personal AI hardware is becoming a serious alternative. You stop renting intelligence, you start building your own infrastructure. So, is Qwen 3.8 Flash Next the best local AI model yet? For a normal laptop or a 24GB gaming GPU, no. For every possible task, no. And until independent testing reproduces Qwen's results under identical conditions, we should treat the exact benchmark gaps carefully. But for users with around 100 GB of memory, or preferably 128 GB and above, who want a private agent for coding, tools, vision, and long autonomous tasks, Flash Next may be the strongest practical local frontier agent available today. It beats DeepSeek v4 Flash across many of Qwen's published agent benchmarks. It beats Claude Opus 4.6 across almost every available direct comparison. And it does this while activating only 6 billion main parameters per token. Most importantly, this is not Qwen 4. It is only the architectural preview. The breakthrough is not that Qwen built the largest model. It is that Qwen may have built the strongest model a serious individual can realistically own. The cloud AI era was built around renting access to someone else's intelligence. The local frontier AI era will be built around privacy, control, and ownership. And Qwen Flash Next may be the model that finally begins that era. Subscribe if you want more honest breakdowns of the models reshaping local AI. Because the next frontier AI system may not live inside a distant data center. It may live on your desk,